This video is about the new Mac Studio M4 Max and more specifically about the network performance. So I'm going to test the 10 GbE Ethernet port, the Wi-Fi 6E, and IP over Thunderbolt. This is my lab environment. I use UniFi switches to connect 10 GbE network devices. In the lower part of the window, in the left side, I'm going to use a Mac Mini M2 Pro, which has 10 GbE port as well. In the right side is for this Mac Studio M4. I'm going to use this lab environment to test the network performance for different methods of connection. In the top left, if you go to the macOS system report, under the hardware Ethernet, you can see this Ethernet chip information. So the chip name is called AQC113. It's from Marvell. And in the right side, you can see the detailed chip specification. This is the exact same chip, AQC113, as used in the first generation of Mac Studio, the M1 version. For all the past several years, this 10 GbE chip has never been changed. Of course, it's 10 GbE, it's not lightning fast. It's expected. If it works, there's no reason to change it, right? Then when it comes to performance testing, I do not expect any changes if compared to the similar testing I did several years ago on the first generation of Mac Studio. In the right side, you can see for this particular UniFi switch, I already connected the Mac Mini M2 and the new Mac Studio to the different SFP plus ports. Okay, then in the lower left for this Mac Mini M2, let me run iPerf3 server. And then in the right side, in the new Mac Studio M4, let me run iPerf3 client. By the way, you may notice for the Mac Mini M2, I am using Apple's built-in screen share. Of course, the screen share itself will take some network bandwidth as well, right? But I am using the Wi-Fi to connect to the screen share, which means when I test the wired network performance, the screen sharing thing won't impact my wired network testing result. Okay, just for your information. When it comes to the iPerf3 client command, of course, I'm going to connect to the left side Mac Mini M2 Pro. And first, let me run the default direction, which is upload or sending from the Mac Studio M4 perspective. And let me run it for a long time. That's why I specify 9999. Let me run it. Okay, so the performance is okay, not very satisfying. It's 9.41. Kill it. Then let me change direction to -R, which means receiving or downloading from the Mac Studio M4 perspective. Right? Similar performance, 9.41 gigabit per second. Okay, kill it. This performance is not the best. So why is that? You may know for high-speed Ethernet connection, for example 10 GbE, there's an important factor. It's called MTU size or jumbo frame. In the UniFi network controller, if I go to network setting, you can see I have already enabled jumbo frames globally, which means that particular switch these two Mac machines are connected to is already working in a mode which use jumbo frames. But to make the jumbo frame really works from end to end in the network connection, for every path, it needs to be enabled, which means jumbo frame also needs to be enabled in both the Mac Mini M2 Pro and the Mac Studio M4. So let me do that. Let me configure the macOS network setting for jumbo frame. I'm in the settings network. Then for Ethernet, go to details. See here, there is a MTU setting, but the default value is standard, which means 1500. To change it, you need to flip this configure option to make it manually. Then you can change the MTU. Let me switch it to jumbo frame 9000. Okay. Then in the same way for this Mac Studio M4, I need to do the same thing. Go to hardware, change to manually, then change to jumbo frame. Okay. Now in both Mac machines, the jumbo frame is enabled. Then let me redo the exact same testing again. From the right side Mac Studio M4, run the upload, the default direction. Okay, see, big improvements, right? Now it's 9.9, perfect. Kill it, then run the other direction, -R for receiving or downloading. Okay, perfect, 9.9. To finish the testing, let me run it in a crazy way, which is bi-direction. I want to test the download and upload at the same time to completely saturate the bandwidth for both directions, right? Okay, this time the result is very satisfying. For both directions, it's consistently working at 9.89 gigabits per second. I am very happy about this wired network testing result. Then let's move on to Wi-Fi. When it comes to Wi-Fi, it's the biggest disappointing thing for me about this new generation Mac Studio. Because it's 2025, it is still only supporting Wi-Fi 6E. It should be Wi-Fi 7 by default, in my opinion. Anyway, let me test it. In UniFi network controller, you can see I will use this particular access point, U6 Enterprise IW, which supports Wi-Fi 6E. And in the device setting for 6 GHz Wi-Fi band, you can see I already set the channel width to the widest possible 160 MHz. Then in the left side, I run a spectrum analyzer showing you the 6 GHz Wi-Fi environment. So you can see now everything's very green. So there's almost no any interference, any other traffic for 6 GHz. This is a perfect ideal environment to test the performance. And then I put the two Mac machines pretty close to the access point. It's about 2 meters. I already connected the two Mac machines to the same access point. Then to validate, now they are connecting using Wi-Fi 6E. We can go to UniFi network controller for clients. The first one is the Mac Mini M2 Pro. You can see it's connected using this 160 channel width. It's 6G, which means it is using Wi-Fi 6E. And you can see the TX rate and RX rate. Pretty good, right? Then for the second one, this is for the Mac Studio. Similar situation, 166 GHz. It is Wi-Fi 6E. The TX rate and RX rate are similar to the Mac Mini M2 Pro. Then now I'm ready to kick off the testing. In the right side Mac Studio, let me run this command, testing the uploading sending direction first. And for server's IP address, I already changed to the Wi-Fi connections IP address for the left side Mac Mini M2 Pro. By the way, for screen sharing, now I'm using the wired screen sharing, so it won't impact the Wi-Fi speed. Okay, start it. Oh, I need to start the server from left side. Then run it again. Okay, close to 700 megabits. I'm good with that. Kill it. Then change direction to downloading or receiving. Yeah, similar speed, good enough. Then this time, try bi-direction. It should be much slower for each direction. Okay, aggregated result for both upload and download is close to previous one direction speed, right? And one last try. Let me run 10 parallel connection just to really saturate the bandwidth. Okay, in the left side, you can see the aggregated result. From server perspective, the download is this number, upload is this number. So the aggregated result is close to 100 megabytes. It's good enough for Wi-Fi, especially it's only Wi-Fi 6E, right? Then in the upper left, for the spectrum analysis, you can see for this area, which is for these two Wi-Fi clients, it's orange color, which means they are using a lot of the available bandwidth. But from the waterfall diagram, you can see it's not really red yet, right? It's still showing the yellowish, greenish color, which means there are still a lot of potentials even for this area to be shared by other potential Wi-Fi clients. Okay, so that's why I really wish this Mac Studio comes with Wi-Fi 7 support. Unfortunately, it doesn't. Okay, now let's move on to the very last section of this video, which is IP over Thunderbolt. In this video, I'm not going to talk about the technical details for IP over Thunderbolt. If you are interested, I will put the link to the description of this video. You can check that video. Here, allow me borrow a slide from another video about IP over Thunderbolt. So for this Mac Studio M4 Max, it does support Thunderbolt 5, which theoretically should support much higher transfer speed, but I do not have any other Thunderbolt 5 computers, so I have to stick to Thunderbolt 4 to show you the speed. Let me start with the Mac Mini M2 Pro. I already plug in the Thunderbolt 4 cable between the Mac Mini and the Mac Studio. In the Mac Mini's network setting, I can see this Thunderbolt bridge appears automatically. If I go to the details, click on this button, you can see now it has 4 Thunderbolt ports, and the first one is showing active. This is the one I plug in the Thunderbolt cable. Okay, so then I go to TCP/IP. You can see now by default it's using DHCP. I want to change it to manually, then specify a IP address I choose. Let's say 100.10, and for subnet, let me change it to 255.255.255.0. I'm good. Okay. Then in the same way, go to the right side Mac Studio, repeat the setting. You can see it also has 4 Thunderbolt ports, even though they are Thunderbolt 5. In this video, I have to use them as Thunderbolt 4 ports. Okay, so the third part is showing active. I go to TCP, change it to menu, and change IP address to .100.20 for subnet mask. Change it to the same value. Okay, then we are done with Thunderbolt setting. Even though in macOS they are still showing unknown state, but they are already in the working status. So don't worry too much about the yellow status. Then from the Mac Mini, let me launch iPerf 3 in server mode. Then in the Mac Studio M4, let me use this left side IP address, which I just set for the Thunderbolt bridge. Let me run one direction only, which is for uploading. Okay, it's 36.4. Very good, right? Much faster than the 10 GbE RJ45. Keep in mind, here we are using the Thunderbolt part. The only thing you need is a cable. You don't need a switch. You don't need 10 GbE support in the other end. Okay, then change the direction to downloading. Okay, it's even faster, right? Then run it in bi-direction mode. Okay, so apparently bi-direction mode is slower than only one direction, right? But at least it can achieve 31 plus gigabit per second for each direction at the same time. It's very satisfying speed. Yeah, this part of testing is very simple, and unfortunately I don't have devices to show you the much more satisfying IP over Thunderbolt 5 speed. Okay, this is the end of the video. Thanks for watching.